So
Okay.
thank you, Philip, for introducing me. And I'm really excited to give my talk here to this webinar series. And good morning, everyone. So as Philip said that I gave a similar talk uh, about a year ago at the SCAAHS meeting held somewhere near Tampa, if I am right. But I've updated some of the slides and I'll be talking about heat related illness, but in a more generic sense, illness in a changing climate and how the demography of Florida uh, seems to be raising the vulnerability of the population even further to changes in climate. So the first thing that comes to our mind here is the recent impacts of some of these extreme weather events. One of them is the tragic deaths of several senior citizens in South Florida in Hollywood as a result of power outages in a senior center as a result of the landfalling of Hurricane Irma in 2017. The power outage turned out to be fatal for 17 or 7 or 8, 14 residents in this nursing home at Hollywood. Although hurricane was a wet event, this tragic event highlighted how heat-related illness can cause such tragic fatalities, even with a wet event like a hurricane. And you can see, again, another instance of Hurricane Maria hitting Puerto Rico, where the fatalities are even more. And, uh, and there's a variety of reasons for these fatalities, from hypertension to sepsis and suicide and some chronic diseases like diabetes and respiratory diseases. They get exacerbated with the falling infrastructure as a result of the landfalling of these hurricane events. And a rising or a very clear message that comes out from at least these two events and many more such events is that the most vulnerable sectors of the population, which are the elderly and the children, are most vulnerable to these extreme weather events. And it is clearly illustrated in at least two of these events, which sends a very clear message that certain sectors of the population are far more vulnerable uh, to these events. So, with that brief introduction, let me go ahead and give you the outline of my talk. Why Florida? Why are we talking about impact of climate change and human health in relation to Florida? How is the future climate changing over Florida and across the Southeast US? Uh, some examples of what we can anticipate in a future climate, uh, some examples of weather events that we have witnessed in the current climate and how that could be a reflection of what might be coming into the future. And I'll end it with some concluding remarks. Uh, Please feel free to send me your questions and I'll try my best to answer them uh, uh, in the middle of my talk as well. Now, if you look at this chart from NOAA, which shows the coastal population across the US, Florida comes out very clearly as a region in the nation where there's a dramatic change in the coastal population, both along the west coast and along the east coast of Florida and along Panhandle, Florida. the population increase over the last 30 or 40 years has been 300% or even more. Even when we had the economic downturn, the population was increasing, but not as fast, as rapidly as it was prior to the economic downturn in 2008. But I'm told from some demographers that the coastal population has again begun to rise at the same rate as it did before 2008. So certainly the coastal population across the country has increased, but along the Florida coastlines, we see a far stronger rise in the coastal population than anywhere else in the US. If you look at the yearly tropical cyclone frequency, number of landfalling tropical cyclones or hurricanes in this instance, if I am right, we see close to 1.5 or to two or one and three quarters to two tropical cyclones making landfall in Florida, which is one of the highest and probably matched only in the Carolinas uh, compared to the rest of the Gulf states. So Florida is susceptible to these landfalling tropical cyclones. And the unfortunate thing is that it is rather periodic. On an average, you can expect about one three quarters to two tropical cyclones making landfall every year. So Florida's will see and continue to see some of the highest frequencies of landfalling tropical cyclones in the nation, although I should put a caveat here that some of these studies have shown there are some slight shift in the tropical cyclone tracks, with some of the studies indicating that there are the density of tropical cyclones tracking uh, towards more northern latitudes is more likely in a future climate. But nonetheless, this picture of the landfalling tropical cyclones, at least over Florida, has not seen a dramatic change in a future climate scenario. Now, if you look at the population density change in coastal shoreline counties, and inland counties, you can see that it has steadily increased across the nation. In this first graph on the top left panel, we have seen about in the most recent decade about 450 to close touching to 500 persons per square mile, which is pretty high. And if you were to hone in on Florida coastlines, it's going to be much higher. This is the national average, and that is steadily increasing. And if you look at the bottom right panel, it shows the age of this coastal population. And you can see that in the last uh, 3 decades or so, or 4 decades, the senior population of 65 and older is steadily increasing along the coastal shoreline counties. Even in the inland counties, we see a steady increase, but this increase along the coastal shoreline counties is certainly a red flag in terms of the vulnerability of the population to extreme weather events and changing climate. So the population density change in coastal shoreline counties has increased by 45% across the nation over the last 40 years. And the senior population is increasing by over 80% across the nation and by 208% in Florida. So that's a huge number. And probably this will get updated once the next census is completed. Um, The leading states in the number of seasonal housing units, Florida leads that and leads by a huge margin compared to the other coastal states around the nation. We have close to 800 dwelling units in the coastal watersheds. that again speaks of the huge coastal development that is occurring in our shores. Um, if you look at the social vulnerability index, which is a measure of a, high exposure and high sensitivity to the effects of climate change and low capacity to deal with them. And the pink areas basically are areas with high social vulnerability index. Again, the Florida coastlines do appear, uh, but they're not as pink as probably the Texas coast is, or probably the coast along California and such. But nonetheless, the fact that these pink spots do appear in heavily populated shoreline counties in southeast Florida and along the Florida Peninsula raises again the vulnerability of the population to changing climate and extreme weather events. So high exposure and high sensitivity to the effects of climate change and low capacity to deal with them is certainly a huge factor in considering the impact of human health uh, from effect from effects of climate change, at least in Florida. So why Florida? The population has increased by over 300% in the last 40 years along the coastal shoreline. The senior population along the coastal watershed counties in Florida has increased by over 208% in the last 40 years. As of 2010, Florida has the highest number of dwelling units in the coastal watershed counties in the nation. The social vulnerability index is high in Florida coastlines. Florida is home to many extreme weather events, tropical cyclones, even droughts, heat waves, deep freeze events in the winter, and then, of course, the wildfires as well. So, how is the future climate changing? So, I have borrowed some of the older figures. These are been updated with the more recent National Climate Assessment that was released in 2018. But nonetheless, many of these projections still remain the same. The observed annual average temperature for the Southeast US and projected temperatures for two different emission scenarios are shown. And you can see that there is almost 3 to 4 degrees centigrade Fahrenheit rise in temperature by towards the end of this century. Now, if you observe, I was talking about Florida in the previous slides, and all of a sudden, I have moved to a more coarser region, the Southeast US. And that's probably because, not probably, but that is because of the coarse resolution of these climate models, the global climate models used in the IPCC, which becomes more uncertain in its projection as you begin to hone in to smaller and smaller area like Florida. So the projections from the National Climate Assessment largely is focused along the four sectoral regions: the Southeast, the Northeast, the Southwest, and the Northwest. Uh, and um, uh, and that is largely the pattern that is used in the National Climate Assessments, and that's because they're limited by the resolution, the spatial resolution of these global models that are used in IPCC. Uh, so the regional average increases are in the range of 4 degree Fahrenheit to up to about 8 degree Fahrenheit. And as you can see, as you go further in time, the uncertainty range begins to balloon and increase, and that is inherent in the nature of the problem. Um, if you look at the projected average number of days per year with maximum temperature uh, over 95 degree Fahrenheit for mid-century 2041 to 2070 compared to 1971 to 2000 for one of the higher emission scenarios, you can see that Florida and southern Georgia appear very red. That is in the sense that there's going to be increased number of days with temperatures above 95 degree Fahrenheit. which again raises the vulnerability of this population uh, to heat waves and heat strokes. If you look at the projected difference from, again, with the maximum, so I think I've repeated this figure over again um, by mistake. Uh, it's the same figure, which is basically showing you that in a future climate, the number of days with over 95°F is going to be pretty high over Florida, southern Georgia, and parts of South Carolina and along the Gulf coastline. If you look at the sea level rise as well, the southeast Florida and along Panhandle region, there's a very high vulnerability to sea level rise, and there is a growing consensus that we can expect about 2 to 3 feet of sea level rise in the next towards the end of the 21st century. Now, in our lab, we have attempted to go to much finer resolution uh, in the sense that instead of focusing on the entire region of the Southeast US, we have tried to focus over Florida. And we have used an approach called dynamic downscaling, where we take the data from these global models and we downscale to a specific region. And in this case, it is over Florida. And what I'm showing you over here is the topography of the land and the topography at the ocean floor. On the left panel is from one of the IPCC models. This is the NCAR model run out at Boulder. And on the right is our model showing the land topography in shades of green and brown, and the topography at the ocean bottom shown in shades of blue and red. Red being the deeper regions of the ocean, blue being the shallower parts of the ocean, likewise green being the low-lying areas over land, and brown being elevated parts of over the land. So the units are in meters. So brown shade over land is about 50 meters above sea level. Green or dark shades of green is almost at sea level. Likewise, uh, blue, deeper shades of blue are almost at sea level, and it goes down to red at 3,500 meters, or about 3.5 kilometers, and even deeper. And you can see at the coarse resolution of the global model, which is acronymed as CCSM4 on the left panel, the resolution is pretty coarse. The coastlines are not very well resolved. The ocean is not as deep, and even the ocean topography is not very clearly represented. And the resolution of the global model is about 150 kilometer by 150 kilometers. On the other hand, when we run our regional model, which is run at 10 kilometers, many of these issues are resolved reasonably well. The coastline is far better resolved. The topography features over land looks more realistic, and likewise, the ocean bathymetry looks far more realistic in our regional model. And this has implication on the climate simulation. So this panel is slightly busy. The top row is showing us the change in precipitation in 2041, in a 20-year time frame, 2041 to 2060, relative to 1986 to 2005. Now, Shades of blue suggest that the future climate is going to be wetter. The columns represent the four seasons. DJF represents December, January, February. MAM refers to March, April, May. JJA refers to June, July, August season. And September, October, November is represented by SON. So the top row is the projected change in precipitation from the one of the global models of the IPCC. This is from the IPCC, uh, the fifth assessment, CCSM4, and you can see consistently in the winter time, DJF, and in the March, April, May, the spring season, as well as in the fall season, there seems to be a marginal uh, wetting relative to the future current climate, 1986 to 2005. Uh, the middle panel, which is referred to as the RSM ROMS, is our regional model, which is again a coupled ocean atmosphere model, but run at 10-kilometer resolution. We see broadly shades of red and brown, which is suggesting that at least over peninsular Florida in DJF, in March, April, May, June, July, August, and SON, in all four seasons, the future climate is likely going to be drier in all four seasons relative to the current climate. And it runs contrary to what the global model is suggesting. The bottom panel is our own regional model, but in this case, it is not coupled to the ocean model. We borrow the sea surface temperature from the global model and force our regional atmospheric model. And we begin to see a similar kind of a projection as the global model in the bottom panel. That is the panel numbers Y, Z, AA, and AB. You see that in DJF over Peninsula Florida, the future climate is going to be marginally wet compared to the current winter climate. And likewise, in the fall season, we see that our regional model, RSM, is projecting and that it's going to be marginally wet compared to the current fall season. So these projections seem to suggest that if you run a high resolution climate model, which is coupled to the ocean model, you seem to get a slightly contrary projection than the global model. That's one thing. And if you were to run the high resolution atmosphere model forced by ocean temperatures from the global model, you more or less see the same, qualitatively, the same kind of precipitation projection as the global model. In other words, one may conclude that the air-sea interaction at these high resolutions somehow impact the continental or the peninsular Florida climate over the land regions. If you look at the sea surface temperature change between the two periods, 2041, 2060, and 1986 to 2005, the top row, the panels in the top row, are from our regional model run at 10 kilometers. The bottom row are panels from the global model. And what I want to highlight here is the warming along the West Florida shelf. Our model projection seems to suggest that the West Florida shelf is going to warm considerably in a future climate. And you can forget about the other two panels that are measuring the ocean temperatures below the ocean surface, but there's a consistent warming of the ocean to a certain depth below the ocean surface over the West Florida shelf. In the global model, the West Florida shelf is so shallow that it is not properly resolved in the global model. And so it is not able to resolve the changes in the ocean temperatures over the West Florida shelf. And this change in the West Florida shelf has an implication on how the future climate is going to evolve in Peninsular Florida. And we argue that this is one of the reasons why our regional model projections are different from the corresponding global model projection. Another important thing that people are observing is the change in the amount of evapotranspiration. There is greater amount of evaporation that is occurring over land in large parts of the land over across US, but especially over Florida. And that is largely because the temperatures are increasing. And this is the observed trends in actual evapotranspiration. This is not a projection. And this has a very important implication on the climate and on the wildfire season, because as you begin to evaporate, you begin to dry the vegetation far more, and especially in the dry season in the spring, it becomes far more vulnerable for wildfires and therefore poor air quality. So how is the future climate changing? The surface temperature, at least from the National Climate Assessment, is projected to increase by 4 to 8 degree Fahrenheit broadly over the southeast US. The vulnerability to heat waves, days with maximum temperatures exceeding 95 degree Fahrenheit, is projected to increase by several weeks in a future warming climate. There is likelihood of increased wildfires in the dry season, and especially over Florida, because we have a distinct dry season in the winter and in the spring season. And with this increased evapotranspiration, the vegetation is going to get drier and raise the likelihood for wildfires and poor air quality as a result. Disruptions to essential services on account of the projected increase in frequency of severe weather impacts are going to raise the vulnerability of the population. Now, these are some projections, results that we have gathered from the literature as well as from our own work in our lab. But I wanted to end the talk by giving some examples of some future events, anticipated future events that are already beginning to occur in our current climate. First example that I want to take is the example of Hurricane Michael. Then I would like to bring about the Memorial Day heat wave of 2019, talk about some vector-borne diseases, which which has got some mixed results, at least based on the data I was able to collect for this current year. And then the threat of rising agricultural production, which again raises um, a lot of questions about health-related risks. So Hurricane Michael, first let me bring this slide up, was actually a category, it was revised as a Category 5 hurricane after the season ended. And this was the first Category 5 hurricane that has made landfall since Andrew. So this was certainly a very, very strong storm that hit us. And if you look at the heat content or the ocean temperatures over a certain depth in the Gulf of Mexico, you begin to see that the West Florida shelf was extremely warm at the time when Hurricane Michael went past over it and made its landfall over Mexico Beach. And that is one of the reasons, because of this very warm ocean temperatures over the West Florida shelf and just off of it, that it was able to tap that heat energy from the ocean and strengthen itself to a Category 5 hurricane. Now, this warming of the West Florida shelf is uncannily very similar to the kind of warming that we have seen in our climate projections that are discussed earlier. So, should a tropical cyclone form out in the Gulf of Mexico and track like Hurricane Michael did in a future climate with a very warm West Florida shelf, then it raises the likelihood or the possibility of some of these hurricanes making a landfall as a Category 5 or a very strong hurricane. Many of the global model projections, unfortunately, as I said, are not able to resolve the West Florida shelf well enough, and therefore their estimates of looking at the potential intensity of these tropical cyclones in a future climate are underestimated in some ways. If you look at the heat wave that happened this year in the beginning of May or towards the end of May, the Memorial Day weekend in 2019, it lasted for several weeks and it broke continuously several records because it was very unusual to have heat wave in May. And from May 17th onwards, which was the first day of the year with 90 plus temperature, and it remained so for a few weeks after breaking many temperature records. So this is again a very unusual heat wave happening so early in the year, but this is again something that could happen more often in a future warming climate. If you look at from a paper from Monahan in 2016, they looking at the meteorological factors and other factors, uh, they were able to assess the suitability of Aedes aegypti mosquito in 2000 in July in 50 different cities, and Florida pops up with a high potential abundance of this mosquito. And this mosquito is a cause for many of these deadly diseases like dengue, chikungunya, and you can see, fortunately, in this year, uh, only three cases of dengue were reported in Miami-Dade County, and in case of chikungunya, they reported only travel associated cases, and there were no locally adapted cases across the nation. So we have been lucky, and probably also it was well monitored. Uh, uh, Knox et al. In 2017 did a survey amongst six state climatologists across the Southeast US, and they came up with several conclusions. They felt that the southeastern region is well poised to increase in agricultural productivity despite increased likelihood of droughts, because rainy seasons will continue even in a future climate, which can produce adequate fresh water for agricultural production if it is used efficiently. There have been recent legislative actions, especially in Alabama and a few other states, which gives greater impetus for farmers to consider sustainable agricultural practices. And so there is a tendency for increased agricultural production. The length of the growing season, availability of open land, ample sunshine is attractive to maximize agricultural production through dual cropping and new crop varieties. As a result, you can see that the citrus industry is beginning to reappear in the Southeast US. And also, there is a migration of sorts happening, the Southwest being in almost like a perpetual drought like situation with tremendous amount of water crisis. Uh, Doing agriculture out in the east seems to be far more attractive. Um, There are, however, challenges. There's greater competition for water resources with increasing population. Several crops in Southeast are already growing at the thermal limits. Increased demand for irrigation, therefore, there will be an increased demand for irrigation to keep the temperatures down and increase the agricultural productivity. Changes in farm size lead to how they cope up with the resiliency to climate through changes in crop choices and cropping patterns. Uh, and increased agricultural productivity uh, raises the vulnerability of ag workers because more uh, they're employed far more now with increased agricultural production. And so these are some of the challenges that one has to be looking at in a future climate. So in conclusion, I think Florida is heading to be a complex region to combat mitigation of future impacts of climate change, especially related to heat-related illnesses. The rising development and population of coastal regions in the state is a challenge in itself. The meteoric rise in the senior population along the coast should raise red flags in terms of healthcare and possibly protecting them from environmental hazards like heat waves and tropical cyclones. Expansion of agricultural productivity in Florida is going to raise the vulnerability of ag workers to impacts of climate change. Several current weather events have played out a scene from the future, as I've illustrated in some of the examples that I've shown. Other anthropogenic impacts like urbanization, migration, irrigation show moderate changes to local climate, and sometimes one begins to wonder if we can engineer ourselves out from impacts of climate change. But most importantly, one needs to mitigate rather than the impact by moving towards a sustainable growth. Thank you all. That is all. Thank you.
Well, thank you so much, Dr. Misra. We will go ahead. Let me pull back up my slides. We'll open it up for question and answer. Once again, you can use the chat box there. Just type in those questions in the chat box, any comments, any questions that you have. I'll give folks just a few minutes but to think of those questions. And as you're thinking of those questions, once again, feel free to type those in. I'll go ahead and take the opportunity to talk a little bit about what the Southeastern Coastal Center has coming up for our webinar series in 2020. I'll have the webinar schedule up here on the screen. I mentioned that Dr. Misra was part of our State of the Science meeting from 2018, looking at heat-related illness, and a lot of our webinars have been on that topic, HRI in agricultural settings. And in fact, we have one, Dr. Greg Stanwood is going to be looking at that a little bit as well in February next year. But we have some other topics here, and a lot of those are related to substance misuse and well-being, mental well-being, vulnerability in rural communities. And so you can see that's one of the trends of the research and outreach that we're doing in our center. So once again, I want to allow for questions to come in through the chat box. And I know we have one, so I'll go ahead and let Dr. Misra get to that one. But then as you think of others, please type those in as well.
All right. So I have a question from Juan Luke here. What about the threat of droughts and wildfires? Will this be more of a threat in the future also? Yes, it looks like this will be more of a threat in a future climate. As I had shown you earlier, there is a increasing trend for evapotranspiration in a future climate. So that increases the tendency for the vegetation to dry in especially the dry season, which is likely to increase the vulnerability to wildfires because dry vegetation is considered as fuel for wildfires. So certainly that if this continuing trend of evapotranspiration, increasing evapotranspiration continues, which is largely forced by increasing temperatures, then yes, the threat of wildfires in a future climate will increase. Likewise, we see the threat for droughts as well. And one of the reasons why we see the increased threat for droughts is in a future climate, there is a tendency for the rain events to become far more severe, but fewer in between, in the sense that for a longer period of time, you will see dry days, and then it will rain at a very high rain rate, with a very high rain rate. So in other words, it accumulates the moisture in the column, and then it squeezes itself very hard and produces huge, stronger rain rates. Now, these stronger rain rates then become a problem in the sense that they don't infiltrate as efficiently as lighter rain rates would through the soil. And so they run off more easily, and therefore the land continues to remain relatively dry with these very heavy rain events. So these factors have to be considered when we begin to anticipate droughts in a future climate. I have another question from Pat Harden, which says, with urbanization comes paving of recharge, destruction of forest, wooded cover, rooftops, heat reflection, etc. How does this not have more than moderate impact on climate change in Florida? Um, I think we are talking about scales here, in the sense that the urban areas, we are getting down to scales of several hundreds of meters compared to the total area, land area over Florida, which is much, much larger. So certainly, in a microclimate sense, yes, we see a huge impact, but in an aggregate sense, the impact of urbanization and impact of irrigation seems to be slightly moderate uh, at these spatial scales, um, regional spatial scales. But if you get down to very high resolution, then yes, and to very small spatial scales, then you begin to see the impact of urbanization and irrigation and other anthropogenic effects to be far more stronger. But when you begin to aggregate over larger spatial scales, then their impacts begin to diminish.
Are there any other questions or comments out there? We'll hold off on our closing up. Oh, we have another one. So
Okay. This is a question from Carissa Wickens. In animal agriculture, we're conducting research on heat stress and heat tolerance in livestock species. So we're addressing these issues, challenges, but could you comment generally on what we should do to address heat-related concerns? I'm not a health expert to really suggest what exactly can be done, except to claim that the likelihood of such events are going to probably increase in a future climate. And how do you plan to reduce the vulnerability of our population to such heat wave events, especially in the summer when it becomes quite hot and humid? And especially in regard, in your case, the livestock, or for instance, the agricultural workers who are working in the farmlands. is something that probably the public health experts need to really pay attention to.